This conference will now be recorded.
Okay. I think you can just go ahead.
Sounds
Unless I
good.
need to make
Maybe
a presenter.
let me share my screen. Actually, let me open up the file first, and then I'll share my screen.
There you go. I see I
Okay,
see the doc.
sounds good. So, thank you for joining. In the agenda today, we said we're going to look into the latest additions that were made into the, from the 0.5, we created a 0.6 working image, and we started adding specific changes that were identified based on review. And sorry, there's some noise in the background. If we could just have everybody mute, that'd be great. Yeah, so it started with some feedback that we got from our Seagate engineering team regarding the signal integrity or the termination, the capacitor termination options if we want to maintain compatibility with our existing SATA and SAS SKUs and avoid having to create a separate SKU for this. So, and as we were ideally envisioning the original diagram, and Alvin, you can, if you're on, you're the expert in this area, and if you want to take over, that's fine.
Okay. So what we've got is basically SAS 4.1 goes with the 178 to 265 nanofarads like PCIe, but it's only on the receive side on the SAS drive, which is the lower right hand, that one. And the U.3 on the host side has the PCIe value on both transmit and receive. So there's no issue with the capacitance value per se, since all this was based off the U.3. If the U.3 works on other channels besides the standard SAS channels, the rest of the E pins, then this should be an acceptable configuration for the SAS drive to go with the 4.1 version of the nominal 220 nanofarads. The real question that comes up is the SATA with the 12 nanofarads max. And we are in the process of putting some units together to test that. We don't have those tests done yet, but as soon as we get that done, we'll come back with the information on that. So from a hard drive standpoint, if you can just pick the configuration at the end of the line, this would be the lowest cost solution to keep you from having multiple assemblies and boards and everything going down. Keeps it at only 2 instead of, worst case would be 2 new SKUs for the NVMe HDD. And so this is an effort to avoid that, to keep the costs down.
Question?
Yeah.
Yes.
Oh yeah, this is Patrick with Toshiba. Just a couple of questions on the notation. You mentioned, Alvin, that it's receive only on the device that takes the capacitor in the dual port configuration. But I don't know if this is following a convention that maybe I'm not intimately familiar with, but when I look at this and I see dual port NVMe HDD SAS connector, I presume that that's from the device side perspective. So you said receive, but I would infer that the TX means we're sending out from the device to the host on that one. So when you say receive, is the labeling, you know, will people knowledgeable with this be able to do the right thing from the labeling? Because it's not obvious to me the way the picture's drawn. And my second question goes to the comment about the NA in the table. And does NA mean 0? I can omit the capacitor, or what does NA mean? Kind of along the same
means, okay, it means not applicable. But for the first question, there's a note in the drawing that says all TX and RX designations are with respect to the host. He's got his cursor on top of the note.
Oh, okay. That's
Which
yeah,
is
that's below my eye
of,
level.
yeah, that's the convention that PCIe uses.
Okay.
Everything is based on the host. So if it says TX on the SSD or drive or target device, whatever it is, that TX is the host TX, and it's a receiver on that end device.
Okay.
And I wanted it to put it in this way, but I'll do a complete table like they did in the SFF TA 1001 once we figure out what these values are, for sure.
Can we put in parentheses device RX in here?
Yeah.
Just to be clear, and put it like, you know, next to that in terms of showing what host TX and then device RX.
Yeah, that's not a problem.
That would clarify it and help it. So again, this is TBD until the testing is complete. We are not sure that, you know, this is the final answer, but this is our recommendation at this point, and to avoid having additional SKUs, and that means basically the single port version would have capacitors on both, and the lower value on the receiver. Any comments other than what Patrick indicated?
So I can build a single port NVMe HDD with a SAS connector, right? If I want to achieve Gen 4 speeds or something like that.
Yep.
So I'm not sure the single port, dual port designation is the primary one here, or is it the type of connector that's being used?
Yeah, you're right. I think this designation should have said dual lane, because we're not really sure we're going to do dual port in the first place in terms of, or for this specification, we're talking dual lane, right?
Well, I think there's another statement in here that says to reach PCIe Gen 4 speeds,
Yeah,
we need to use the SAS connector on the device side, right?
correct.
So we would use that even if we do a single port / single lane NVMe HDD at Gen 4 speeds. We would, I think we would use a SAS device side plug. So I'm just referring a little bit to the combination of single port, single lane, and connector is not. It's not necessarily a one-to-one mapping at all times the way it's kind of shown here.
Understood. So it really is a SAS connector, but we maybe should indicate high speed NVMe versus low speed NVMe or Gen 3 NVMe compliant. We need
Let
to,
me,
Yeah, or just keep it separate, right? I mean, if the connector determines coupling capacitors, then let's just keep it like that. And there's another section that maps the speeds to the connector. You know, I don't know if it has to be all in one chart necessarily, but
in this
well,
chart, we
let me interrupt here. That is not necessarily the long-term plan, because the number of drives that are made with SATA connectors, those tools wear out. And the earlier discussion within this group was that we may take the changes that were made to the SAS connector and put those back into the SATA connector
okay.
to do a single port there. So maybe the easiest solution here is say SATA connector, NVMe, HDD, and SAS connector, NVMe, HDD.
that would be the better approach. That's what I was
Yeah,
going for. And,
yeah,
and I think it's, you know, the problem with having Gen 4 is it requires the SAS 4 improvements on both the plug and the receptacle. So that's just, you know, even if we do improve the SATA to work in that, it has to be at the same level of improvements as a SAS 4 plug.
yes, okay.
Yeah, so let's simplify it and just omit the number of ports and just talk about SAS connector and SATA connector NVMe implementations.
And then add the designation of host TX and drive TX RX.
Yep. So it's clear. So somebody reading that note will see the parentheses and identify what that means. And I took a note here. I had a table mistake. I need to hook it to the reference versus hold on. All right. Unless there are other comments, we'll move to the next subject, which was the activity signal from both the SATA connector and the SAS connector. We're going to use that terminology. And we're going to have to clean up this dual port, dual lane. We meant it so that you can support either. So in that section, let's see, why don't I have that latest copy? Because I did have it pulled from the right. So this is not the right copy. That's the one I downloaded. Okay, this is the right one. Now it's going to be slow.
3.7.
Yeah, I have it here. Okay. So the original, you know, in comparison to what I just showed earlier, the way it was in version 5, we were going to go with SAS implementation, mimic the SAS implementation. And I think that did not correspond well. We have two different drives with different drive capabilities, sync capability, in other words. And the drivers since the drivers are different and since there is already a definition on the EDSFF for an activity green LED, I think after further discussions, I think we suggested that we would mimic the SSD EDSFF green LED functionality, but not reference it because it's not the same, and we want to keep it a little bit in terms of we're not driving an LED directly. We're not adding an LED to the drive. It's a signal out of the drive that will drive an LED that's on the system. That's the difference here. That's why it's kind of a signal definition versus an EDSFF green LED is right on the module. And so in this fashion, we kind of mimic the definition of power on, where the LED signal is on, and activity at 4 Hertz nominal blink, and then the LED off or the signal off will drive the LED off to indicate there's no power. And we indicated that the system designer is required to redrive this signal to the right LED spec that they're choosing on their system. So that way, if the driver from a SATA drive is weaker, it can be redriven anyway, so it doesn't matter.
So I had a couple of questions about this section too. This is Patrick. Where do we look for sort of all of the signal-related activity for this? So, for example, in the SATA spec, is it active high or active low, and what the voltage threshold is, whether it's a low or a high, and then they have some example of the driver if you're going to drive on the host side and all of that stuff. That's not in this document, but I was under the impression that NVMe SSDs didn't have an activity signal at all. So the fact that you're telling me that EDSFF does, that's interesting to me, and I want to go investigate that. But where do I go? And is there going to be another spec that follows on, or another group that's going to pick up kind of that other level of detail of the physical layer aspect? In SATA, it's all in the same document, but it looks like here maybe it's not all going to be in one.
We're referencing the SAS and SATA pinout, and we're saying that we're matching the signal polarity of that spec. I think we need to make that very clear in the areas where only in the areas that required additional clarity, we added a section to define those pins. Otherwise, we're referencing the SATA and SAS spec. If you feel like it's a good idea to add this to the spec instead of just referencing those standards, that we can look into that and do it.
Yeah, I don't know enough to know one way or the other. I just I need to be able to point my engineers to the right reference material. That's all. And so it's help if there's a trail of breadcrumbs that leads from A to B to C to D, right?
Right.
What I had kind of gathered, or at least my understanding is that at the NVMe level, the NVMe doesn't have any requirement for activity signal. They have a pass-through command, as I understand it, for SCSI enclosure services style commands, so that they can send a command to some unit on the host via the NVMe MI a command structure that could blink an LED or do something along those lines. I wasn't aware that there was actually a hardware signal on traditional NVMe devices, and if there is that something that customers want to retain or not?
Yeah,
because I feel like we're kind of carrying forward with the traditional HDD model, but the target, I'm not that familiar with some of the details of the target requirement in NVMe space, and are we mapping the requirements that aren't needed or useful or something, right?
Yeah, so Patrick, I think
to the group.
Yeah, I think part of this, Patrick, might be the EDSFF drive. The activity LED is on the drive itself, right? So it's on the device, so it doesn't it doesn't come out of the device. But given that this is a 3.5-inch HDD form factor, the activity LED for any platform with the 3.5-inch drive is driven back by the device into the chassis, right? That's where the activity LED goes. So really the question here is, do we not have one? In which case, any tri-mode platform where you would expect the same, let's say you have a backplane design that accepts SAS, SATA, and this NVMe drive, you would have an activity LED for SAS and SATA, but you put an NVMe or an NVMe HDD in there, you get nothing, right? Now, whether you use it or not really doesn't matter, right? Some enclosures might not use it if they're in lights out data centers. They may not need activity LEDs, but just from a standardized behavior point of view across the three protocols that all use the same pin out, if we drop the activity LED for a PCIe device, then anybody who would want to build a tri-mode backplane would not have activity LED at all for NVMe, right? Because the drive for that for SAS and SATA would come straight out of the device. Now, EDSFF has another fault LED that's driven in. That's a different thing, right? For the host to drive the amber LED on the device. But the other choice, then we would have to go add a green LED to the drive, to the 3.5-inch drive, and all redesign our carriers, and that's not really a viable idea, right? So I think that's partly where the confusion here comes. So I mean, so that I think is the question we're trying to answer, right? So and I don't know if that is really, is that kind of, I mean, are you thinking that we should not have an activity LED?
No, I have no, thank you. That's a very helpful explanation for me. You gave me just the pointer that I just needed there. Which is, the kind of connection of both sides, right?
Yeah.
Right.
So now one thing we might want to do. Oh, sorry, Mohammed, go ahead.
No, go ahead. All I'm saying is we're trying to tie it all together so that we're satisfying the traditional behavior of an HDD and then linking it to the expected look and feel of an EDSFF SSD, NVMe SSD, and kind of we discussed it, and that was the happy medium that at least we came up with. We're running it by everybody. It's not a decision. It's just everybody's opinion here.
Now, one thing that might be worthwhile doing, and whether we do it for this release or in the future, like you said, Patrick, it might be worthwhile doing I don't know if it's worthwhile putting a sample circuit in here on what a redriver would look like, or maybe a stronger statement that the activity signal coming out of the drive is isolated from the LED drive. I don't know if we need a stronger signal that says, to allow for variances in sync or between the three, that any enclosure should have a redriver for the LED so that the drive doesn't have to worry about the sync current, or we specify the maximum. Mohammed, I don't know, can we say rather than 20 milliamps, the maximum a drive will be able to do is 5 milliamps, and then you have to deal with the LED thing in the enclosure? I don't know how we fix that in do we state the absolute minimum sync current that this pin can take, and then say, leave the enclosure designer to deal with the fact that the signal syncs 5 and they need 20 for their LED and or whatever brightness setting they're going for. And is that
right? I think the answer to what I would like to see personally is I think all of that should be written somewhere, and I think that all of that stuff is in other places, and as long as there's a clear connection that says the blah 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 in this document is applicable, for this usage, then that's okay with from my perspective, because I know that a lot of that material is, for example, in the SATA specification, for example, and I presume it's also in something to the similar effect is in this EDSFF form factor specification as well.
Right.
As long as there's somewhere that I can point to, either in SFF committee or somewhere that kind of contains the appropriate reference.
Yeah, but we don't want to reference this spec because this is a spec for an LED on the device itself, and that's what concerned me about referencing this spec. Instead, we continue to reference the SAS and SATA connector spec from a polarity and sync capabilities. And I think what we should do here is make a statement that will assume the lowest of the two in terms of the sync capabilities and stick to the SATA sync and say, that the system designer should assume this lowest level of sync capability and provide additional driver capabilities. So in that function, that was my first attempt at it. If you guys can help me rephrase it and put a circuit there, I can probably try to do that. But thanks for the question. I think that clarifies.
I think that'd be fine. Yeah.
Yeah, I'm trying to avoid having to repeat what's in the SATA spec and SAS spec and put all that information here just because it could change elsewhere and then we have it in two places.
Yeah,
well, that redriver is already in the SATA spec as well. So
yeah, references are always better unless you really have a compelling need to copy it in for that, just for that very reason of synchronization. So
right.
I guess another thing that we have going here is that I don't see any expectation of the LED requirements in SAS or SATA as far as the circuitry changing. I mean, it's been there for 2 decades.
Yeah,
that's true.
But
and
reference it. We can put a copy of that in here and say that's for information only. And I think that would be helpful. I think.
Yeah, it's an either or. It's either going to be this or this, and here's what you need to make sure that it works whichever one it is. I think that's probably what Patrick's worried about, and those other interface drives are not going to change in that area.
Yeah, if they do, they break backwards compatibility with everything that's already designed, right? And so it would be highly unlikely that the LED requirements for either SAS or SATA would change, right? So
right.
Yeah, so I think referencing them should be okay. I think so.
Yeah, and I don't know if this is appropriate at this point, but there was a request from Ulrich Hansen from Microsoft. I think there's a suggestion that we could uplift our formatting within this document to make it more aligned with the data center spec of OCP data center spec with additional um, change IDs and spec ID references. So I would let him speak to it if we're done with this section. All right, you want to make your
Yeah,
suggestion public, I
yeah,
guess?
yeah. As I'm fairly new to this project, I took a look at the document, and I have some bandwidth in the next few days, so I propose that maybe I spend some time on driving some format change into the document to make it align a little bit more with some of the other spec templates. One of the things I recommend we do is we introduce kind of requirement IDs that we have used in the OCP data center SSD spec, which made it actually quite convenient when these things are reviewed across, different organizations and things like that, as well as for change control. So my proposal was to create basically a version of this document that doesn't change the content, but focuses on structure and formatting, and then show that to the group in the next meeting. And if we like it better, we can go with that. If we hate it, we stick with this one. So, um, I was offering up and proposing to do that. At the same time, I would probably take a look at the NVMe section specifically, just because NVMe is such a large body of requirements and specs, 600, 700, 800 pages, however many there are across multiple documents. To really, create a tighter reference back to the original NVMe specs and just be really clear about what's optional, what's mandatory, using the exact language of the NVMe specs, the underlying NVMe specs. But again, it would be formatting and structure. I wouldn't, make proposals of changing the content in the same step. Once we agree on the look and feel and the structure, we can then go back to discussing the content. Because this has bits and pieces of the base spec and the NVM command set spec and the NVM EMI spec and the PCIe transport spec. All those things are kind of all mixed together in here, and I'll take on the challenge to make an attempt to kind of break it into the right pieces and make sure it links back to the original source specs, in a little more clearly.
And it would be good to keep at least this or these tables as an informational summary in the information section, like we discussed.
Yeah. I think I'll show all the optional stuff. We can. The purpose column, if we want to keep them, we can keep them. I think that's of course all spelled out in the NVMe specs what these things are actually for. The comments column, we can, if we want to keep them, we can keep them. Or maybe as the spec matures, there's less of a need to carry them forward to the final version.
Agreed, but at least for my sake, in terms of development, working on the specific set of features that are called for here, and for any developer who wants to take this on, it's easy for them to just focus on what's called in here. For now, just if we can keep them intact, that way they stay as a reference for information, and we, even though we have that information elsewhere, it'll be separate. I don't know.
Yeah, we always have this version, and it's still hard in the abstract, I think, to discuss. I think next meeting I can just show what it would look like, and maybe it become clear, a little more clear, right? What we keep as informational things, and what is. If I look at some of those things, right? I'm not quite sure. No, we don't have to go through all of them, but some of them are fairly basic in nature. Some of the comments, and we may or may not need to keep them at the end of the day. But certainly the what's mandatory and what's optional for the HED relative to the generic NVMe spec, that we want to be really clear on, right, and carry all that forward.
Yeah. And Patrick, I'm not sure what this note is, but it could be just a mistypo or something.
I have no idea how I got there.
Yeah, probably just as you were reviewing.
Yeah, it's good. It's a good new word.
Did I make a paste by accident, maybe? I don't know.
I didn't want to delete it with a.
I think you can delete it. I don't know what that is.
You
You
know,
have to make it
just as an
defined
example, right? I think one thing that's not in the list right now is firmware download, some very basic command, which interestingly enough is not a mandatory, command support in the NVMe spec. And again, if we actually go back and take in the complete NVMe stuff, then we'll don't run the risk of missing some of those things. Right?
Agreed.
But anyway, it will become a little bit more clear, I think, when I show it in the next call. And I'm going to time box my energy on this, right? I'm going to create kind of a draft, and if we like it, we can use it. If for some reason we don't like it, no foul, no harm. We'll go back to what we had before.
Fair enough. All
But if
right.
anybody
Well,
has any other suggestions or ideas around formatting and structure of this document, if you send it my way, I'll incorporate it as much as I can.
So is there any intention to take this to SFF after we get to a certain point, or are we just going to leave it in OCP?
I think we discussed that early on. Jason, Dave, and myself. We talked about at some point is having somebody assigned to carry this forward within SFF for the connector in order to formalize it. I don't think we can keep it in OCP only.
Yeah, the answer may be a little bit different depending on the pieces of this document, right? If it's
Yes.
connector
I
stuff,
think,
form factor stuff, that's kind of one thing. If it's a huge table that says these NVMe optional things are mandatory, that probably doesn't go, maybe that doesn't go anywhere other than OCP, right?
Right, but the connector things, specifically to the definition of connector and usage as an NVMe in NVMe devices, I think it would be more formal to have the SFF spec around that, just like what was done with EDSFF and other stuff.
Well, the complete EDSFF is in SFF. The temperature measurement requirements, the power, the features, all that, the complete description that came out of the EDSFF group got transferred to SFF and it now continues there.
I think the where this kind of lays out is that, well, one thought I have is that it might, even if we do that, it might make sense to wait a while for things to stabilize in the ecosystem a bit. But the other thing to say is that I could see an SFF spec for this, definitely. And you'd have two things. You'd have an SFF spec of some kind that does the pinout and the on the connector and the things that SFF does, and then you'd have a requirements kind of drive spec like which have been coming right from the hyperscalers. You could have a contributed drive spec that is more of a list of requirements like you're talking about, Ulrich. So I think that maybe that's where it ends up. The question is, how quickly do we do it?
Yeah, I think that makes sense to me. And again, right, a little bit the question will be for the latter part, for the drive requirements. Let's say it's a data center NVMe, HDD kind of spec, similar to
Yeah,
what we've done
right.
on the SSD side. I think we have to just look at that and figure out, how, we won't want to create duplication redundancy with the SSD spec, right? That covers a lot of the basics around NVMe management, NVMe, device security, and some other.
Yes.
So
That may be
consistency there is obviously desirable, and Similarly, I think there's work going on a
sort
data
of
center HDD spec, right, in OCP as well, that will talk more about the HDD specific elements. So, is there a need for something, a third thing, or is it just going to be, a big reference back to? I don't know exactly where it will go, right? We can obviously need to figure that out.
I would see there's a possibility of refactoring the SSD specification to include HDD in certain specs.
Yeah,
Yeah,
that's one option.
it makes a lot of
So,
sense.
yeah. So David, going back to SFF, does that take the connector back to the PCIe SIG? Do SFF take the connector back to PCIe SIG then, or?
No. I think SFF doesn't need to go back to the SIG. I mean, you could take the connector to the SIG, but you don't want to do that because they're not going to want to. This is not
Yeah,
their form factor. They're not going to want to do it, right? So
yeah.
the best way for the connector and the pinout, that probably should be spun to SFF, right? And we can do a really rigorous job and make sure it's a solid spec.
Okay.
And the form factor there's no change, right? It's just 3.5 inch or whatever. So I don't think there's anything to do there. So
2
I think
inch.
it's right.
Well, the ideal world is once we're done with 1.0, that we would carry it forward to SFF and get it locked in and accepted. And the hope is we're still waiting for enough validation of the first implementation of the EDUs, the engineering demo units that will be available, in September, and hopefully, once we can validate the various aspects of this spec, we can feel confident enough and move forward with 0.7 and then 0.9, and hopefully we get 1.0 released and move it into SFF. And so at least that's the plan. And it just, there's going to be quite a bit of system level validation that will happen with the POC enclosure that will be available in September, and to verify signal integrity and bit error rates and all the above, and the work around SRS and things, the reset issue that we omitted, and quite a bit of things, including the VDM attestation aspect of the security difference. That's going to be required here versus I2C SM bus on SSDs. So I think, once we're locked in on all that, I think the 1.0 would be complete.
Yeah, I think you're agreeing. You're agreeing with what I was kind of intimating before, Mohammed, which is I think
Yep.
this is a new ecosystem, and so I don't think we should rush it, but let it stabilize a little bit. So a 1.0 spec out of here, maybe that's the right trigger. I mean, I don't know. I don't have a strong opinion one way or another on the timing, but
Just an idea. Yeah.
Yeah.
I think we'll gather enough momentum from the team here and push it into the SFF when it's ready. I don't think we need to push it earlier, because the timing from an availability of production is we have some time before that.
Hey, Mohammed, I have a question on the pin definition. Is that okay to do? Can we go to the single port? Sorry, I don't know who present that. If you look at the RX, okay, sorry, yeah, right here. The S2, S3. See the drive to the drive from host, and the host from drive. Is that is this in the right order, or is it reversed? I just curious that
So the TX, the pinout in the table from the SATA spec and the SIG, agreed that to always reference it from a host perspective. So in this one, I just put the additional notes that this is the drive, TX drive to host, and then host RX from drive. So the receive, this is indicating that this is the driver with respect to the transmitter from the drive side to the host, and this is the receiver from the host or to the host from the drives.
To the host from drive. Okay. In
And,
other words, sorry, go ahead.
and the same thing up here. It's transmitter host to drive and receiver drive from host.
Okay. So S2 is a TX is a plus, and then S3 is TX is minus. I'm just thinking the S2 and S3. I'm sorry, S2 and S3 are they reversed, or is just just to make sure the connector side is okay. Our design has some questions on that.
That's a good point. Did we swap these, or is this the way?
Yeah, just to be.
I think they may have done it to keep the coupling to ground and avoid some.
These are as defined in the SAS. Well, so on the right-hand side, those TX and RX over in the drive column, that's the actual drive function. It's a drive receiver on S2, S3, and it's the host transmitter on S2, S3.
Right. His question was plus and minus, right?
Right.
And
Yeah.
you got
Okay.
you got TX plus, TX minus, and then RX minus, RX plus. I just want to go back to the standard spec and verify, but I believe this
I
was
can look
done.
real quick.
Yeah, thanks. Yeah, they do have some questions on that.
Good observation. And I think I copied it blindly when I did.
I think it's in a file level they can program that, but it's just it's kind of additional step. If we do it right, then can avoid that.
Yeah, I do believe that I copied this straight from a drive spec, but I could have made a mistake, and I don't believe so. We'll find out.
Okay, all right. Thank you, Mohammed.
No problem.
That's correct. It's, oh, wait a minute. It's plus, minus, minus, plus.
Yeah.
So, yeah,
Plus,
those are correct.
Plus, minus, minus, plus. The minuses are around the ground, and I'm figuring there's some impedance reason
Yeah,
why
they've got grounds on both sides.
yeah.
There's a common ground in the middle, but
okay, so
I'm not sure
it's
why they did that.
plus minus ground minus plus. That's the sequence.
well, it's ground, signal, signal, ground, signal, signal, ground.
Right. I mean the signal.
Would you mind sharing the table, Alvin? If you can share, I can make you presenter.
Yeah, I appreciate
Okay.
that.
That's showing up now.
Not yet. Did I not have the authority to make you presenter?
Well, he's
Dave?
trying to share. I see the circle going
Here, I
around.
can. Who needs to be presenter? Maybe I need.
Alvin Cox,
Alvin.
ACS.
Sorry, I was preoccupied. Let's see. Make organizer. Well, okay, I'll make you an organizer.
Yeah, he is a presenter right now, so I don't understand. Yeah, okay, now it did work.
Yeah.
Oh, this is correct.
Yeah,
Yep. Yeah.
it is
Okay.
correct.
It is correct. Got it. Yeah. This I'm sorry. This specification is what's this is which spec is this one? Sorry.
That's a SAS.
Spec. Okay, great. Yeah, thanks a lot for your help.
No problem. Well, I think that covers quite a bit today. If anybody has additional questions or requests, please email us. And I think right now Ulrich is gonna start taking a stab at a new draft formatting, and hopefully we'll give comments and make modifications before we either adopt it or decide to stay with the current format. I personally liked his format. I got a chance to see what he has in mind.
On that dual port table, what happened to S14? Did that get wrapped over to the next page or something?
Oh, did I miss that?
Yeah. And S14 is supposed to be ground.
It must have gotten chopped off somehow. And yeah, because the last pin should be ground. You're right. I can fix that. I'll fix it later. That's a good catch. Thank you. All right, Alvin, then we're gonna get some news from you on the changes that you're gonna do in here in this section on the capacitor decoupling caps. All right,